Hello. Yeah, so everybody's here to talk about the new resource cookbook, right? Is that what this one is? Or were you guys just provisioning audience Oh, come on. People have been talking, like, you know what? You know what? Screw it. I don't want to hear it again. We have a lot of gems. So yeah, some of you are familiar with chef provisioning, been using it in your production environment and teaching me how it's supposed to be used. And some of you are new to it and wondering what it's for. When I made chef provisioning, the reason that I did it was that I'm a developer and I make scale distributed systems, and a lot of the time I don't test them the way that they should. I don't bring them up and do them because there's a lot of things that are a lot harder than they should be. And one of those things is actually getting a machine. Another one is configuring it. And these are all things that I'm particularly bad at doing myself, and so I would like software to do for me, and that's why I joined Chef. Let me bring up the slide. So there's a couple of reasons chef provisioning exists then. The first big reason is that in order to really understand and share what it is you're doing, like our job here is to build distributed systems, and we have good tools for describing what stuff is going to be in a machine. We have Chef. We can put a file there and a template there, and someone can read through the thing and see that there's going to be a service, an Apache 2 service running, and it's pretty easy to read. And it makes it so that we don't have to, when we want to change it, that we don't have to wonder what machine we need to go to, and we don't have to wonder what commands we need to type. We can just modify that description, and it makes the change, and then it's still true. And the next people that we talk to can look at the recipe that we wrote and know what currently is supposed to be true about the cluster. So there's no more going and making changes that there's no more playbooks. There's no more going and making changes that aren't sitting written down in a big long scroll of instructions for how to restart the database. Let me see if this goes forward. Huh. So that's kind of what we used to do with the old ops playbook, and that's really made things a whole lot better for individual machines. Chef has kind of fixed that. We still have one, or a lot of us still do. It's finally changing, and this is the thing that had scared me. I was working on the first revision of push jobs for Chef, and I found that most of the time when I tested it, I would just take the one little server and stand it up and see if I could hit it on my own machine, and hope that when we finally deployed it into the environment, into production, into QA, that it would do the same thing, and that the components would all talk to each other. Because this was mysterious and hard to me. That's way more parameters than I ever want to type, and I didn't really know what most of them were. And it frankly forced me to learn too many things when what I want to do is sit down and write my distributed app. And I think it's going to be true for a lot of people. If you want everyone to be testing the whole distributed app at once, you're going to have to describe the whole cluster at once, and you're going to have to do it in a way that doesn't require them to spend 2 weeks reading a whole bunch of books about things that they don't have expertise in. So that's really the reason. I want to replace that playbook with the same kind of description, that that we had for individual machines. Am I on that? Yeah. So the clusters that we like to have are the ones that we understand. We know that we have 8 database machines. We have 8 data machines. We have 300 web servers. And most of them are things we don't understand because we haven't really written them down anywhere we understand. This is what Chef Metal is supposed to address. And this is a very basic recipe in Chef provisioning. I'm calling it Metal again. It used to be called Chef Metal, for those of you who heard that term and are wondering what happened to it. This is what happened to it. We named it this. So the basic idea of it is you write down resources. This is a chef recipe. The type of thing is a machine, just like you would make a file or a template or a service in a recipe. In fact, you can put files and templates and services into the same recipe that you put machines in. And some people do in order to set up things like private keys that they want to put onto their machines. And if you put lots of these together, it turns out you have a cluster. Now, what actually happens when you're working with one of these is that you're going to have to actually talk to something that can give you a machine. And this is, we have a lot of ways to do that now. We have the clouds, we have VM technologies, we have containers, we have on-premises bare metal stuff like vSphere and Hanlon. And this is designed to make it so that you can talk about the cluster mostly independently of that as much as possible, so that you can kind of think about, as a developer, as an operations person, you can think about how the components connect to each other and what they are separately from the minutia of exactly how much memory is on the machine, what AMI it is, and what instance type you've got, whether it's flavor A0 or small. And that lets you kind of think about your application sometimes and think about the physical infrastructure at other times. It also allows you to do a thing that I think is really important. If you're going to give the developer the power to have some infrastructure, to bring up this cluster recipe for himself or herself, each developer on your team, 5 developers are going to have 5 different little clusters. You're also going to want to take that cluster, you're going to want to deploy it into the test environment and into the QA environment and then into production using the same recipes. And those are not always going to be on the same, in the same place. Like, the developers may want to actually run it on virtual machines on their own laptops so that they can do it on the plane. And you may want to just spin up clusters in Azure or AWS when you're in the test environment so that you can create on demand as needed. But in production, most of the time you can't put it on the cloud because of regulatory stuff, so you're going to have a vSphere or another set of machines that you just that you're layering it on top of. So this is the basics of what it is and why it is. It's kind of a new general idea that we have a whole lot of things that we need in order to make an application. It's not just the files and services and templates on your machines. It's not even just the machines itself. It's the network surrounding the machines. And for most of us, it's also things like accounts on other machines and users. And we're moving into a world where the stuff that is important to our application and our business are not sitting on computers that we own and control. And that list of machines isn't. When we're doing the cloud, AWS and Azure own that list and let you borrow the machines from them. And for example, at Chef, we have tons of GitHub accounts that are really important to us and the permissions on those things. We're just really dependent on things that are off the box. So this is a thing that this is kind of the first wave of these kind of resources. And the end goal is that you should be able to describe all of your infrastructure as code and not just the things on the machines. So the basic workflow for how to use Chef provisioning is that I'm going to bring up, let's take that thing down if I can, and bring up our Atom instance. The basic workflow thing that you're going to do, like say you have a little database application, you're going to end up having a web server. You already got a recipe that can deploy this thing. So you end up making I'm going to call it RB so we get a syntax highlighting. Did I call it a RB? It's hard to move the mouse on that thing. There we go. So the basic workflow is like on the first day when you're making something, you're going to have a little skeleton for your web app. It's not going to do a whole lot. You make a little recipe for it, and you like my app, and maybe you're going to have Apache 2 in here. And you're going to need a database machine. You may or may not know yet where you're going to put these, but right now you're describing it. And then you're probably going to have my app database where you can put your schema onto it. And then you realize, hey, maybe I'd like to get some load balancing in there. And this is a thing that we can do with Chef provisioning as well. So we can make another machine that's exactly the same. And then down here we can say load balancer. Machines web 1 and web 2. So the things that Chef provisioning can do include both the machine and a load balancer. Well, you've also decided maybe that you want your machines to be able to spin up a little bit more quickly than they currently do. So one of the other things you can do is create a machine image. And so in this case, one of the things we could do is we could say recipe Apache 2 recipe my app, and then just say from image web. And what that's going to do is in Vagrant, it's going to spin up a box from just your base box, whatever it is you start with. It's going to do the configuration, and on that machine, then it's going to save it off into an image. And then these machine directives are actually going to take the image that you created before and bring up machines from them, so that you don't have to redo all the configuration that you did before. It can help particularly if you want to make like base boxes with apt in them, because that can take a frighteningly long time. You can chain these images as well. You can create a machine image base and then chain web from base. When you do the machine image thing, we're still living in that abstract world of things that we can do across different providers. So if you were to point this at AWS, then it's going to create an instance on AWS and configure that instance, and it's going to save off an AMI, and then it's going to use that AMI to create the subsequent machines. So you set up a little project like this, and I've got to cut. We have an example project structure. We're sitting here actually in the Chef Provisioning Central repository, and that's a place we just created this week, where you can put example recipes of things that are important to you. Like, here's how I created a VPC. Here's how I created a little C web app. Here's how I deployed all of my monitoring stack. And here's how I get all that stuff to actually hook up to the web servers that are producing all the statistics. That repository, anybody is welcome to contribute to. One of the little cookbooks that I'm trying to put in there now, or that I have put in there, is this Ruby web app cookbook, which is a little tiny Sinatra application whose job is to get one row from one table suspiciously named hello. And this is the only thing it does, because what we're wanting to do is kind of make a template project that'll help people get started when they want to actually bring up a whole cluster. The project structure that we chose for this is one where you have a main cookbook, and this is how a lot of people do it. Is your application already has a cookbook that's got some things in it that can configure specific stuff. So, like, this is the web server cookbook that actually runs on my web server machine. This is the database cookbook that runs on my database machine. You can see it creating the role and the tables and all of the data that the application is going to use. And then so we add one more kind of cookbook, and this is the cluster cookbook. So the database cookbook is going to run on the database machine when it's created. The web server cookbook is going to be run on the web server machine when it's created. The cluster cookbook is going to run on the provisioning machine when the provisioning machine is created. Some people create a machine for it. Some people will actually just run it from their laptop, and it kind of depends on what kind of environment you're creating and how long lived and how self-healing you want it to be. So this is what the project structure usually looks like. We create a cluster recipe that lets someone spin up the whole cluster. They pass it whatever attributes they want. And in my case, I've created a web machine and a database machine that are in fact hooked up to each other. And so there's a few interesting things you can see about this recipe. You can see that these two machines, we've already talked about how they work. We've set roles on them. We've set some attributes on them. And we also did a curious thing. We put it in a machine batch. That's another resource that's provided by provisioning that will let you create a whole set of machines in your cluster in parallel. So if you're going to create 100 web servers and 2 databases, you can put them all in a machine batch, and it's going to do the thing in parallel, because it would be a serious pain in the ass if you wanted to, if you were going to do 150 machines in order. It's really a non-starter, because those things, if they take 3 minutes each, then 20 machines takes an hour. That's not cool. A machine batch is your unit of parallelism. You'll also notice another thing, like after I created my web machine or machines and the database machine in there, I go back to the web machine at the bottom there. And this is just a feature the way Chef generally works anyway. You can actually open back up a thing and make more changes to it. And this is a way of doing very basic orchestration, which is often necessary when you're bootstrapping a new cluster of machines. For example, in this case, the reason that I'm doing this is that the machine Web 1 cannot configure its, it can't set down the configuration file for the app until it has the IP of the database. That means that the database actually has to exist. At the time, so we're going to have to actually wait for that whole machine batch to finish before we can do this. Now, what I could have done is I could have just done that, right? Like, it would have taken me, it would have taken things longer, but it would have been fine. I just preferred to do this do the things that don't actually impact the, don't actually depend on any of the other machines. I'd try to do as much of that in that massive batch at the beginning as possible, and then start those little dances where machines have to wait for other machines to do things, so that you waste as little time as possible in serial configuration like this. You also notice the files directive. This is something I don't talk about enough, and people are surprised, and it fixes their problem. So I'm talking about it now. The files directive on a machine lets you specify a set of files that will be uploaded to the machine before any configuration is run on it. And this is really necessary a lot of the time to put private keys and security things on there, because you don't really want to store those in your Chef server. You don't want to store them in external places for things to get. If you have a private key that you've generated on the local machine, you want to just give it straight to the machine you're provisioning and not to a third party in between. In the case that I'm using it for, I'm actually using it to deploy my application because I've only got one file. And I kind of want to do that because after I've deployed this thing, one thing I'm going to want to do is change my app when it doesn't work and rerun the recipe and have it go back up to the cloud and see if it still works. So after you make your basic project structure, the stuff that works, you can actually run it. You have seen the basic run already as you walked in. Let's see here. We're in. Oh, this is Chef Provisioning Central. You had to make me go out of that directory. Let's see. Ruby Web App. And this is something you'll be able to check out. I don't think I've checked this repository in, or this project in yet, but it'll be checked in by the end of the day. And what were we? Oh, we were running it. So you look at this, and you see another feature of a project. I'm running 2 recipes here in local mode. And what's going to happen is I'm going to run. It's going to run the AWS recipe, which is what sets up and tells the rest of the recipes where I want my machines. And in this case, I want them on AWS. There's an AWS, Azure, and Vagrant recipe in here, and all of them have slightly different configuration. The other thing that it does is, since all of my machines at least have the same set of options, like the same instance type and the same AMIs that I base them off of, they're all going to be Ubuntu 14. I set up one set of machine options at the beginning. And I'll show you that real quickly before we run the thing. In the case of AWS, I don't need to specify anything because I'm OK with the default options. So the Azure one might be a little more interesting. I have to specify my cloud service name and storage account name and what location it's going to, the machines are going to be in. I could specify image IDs and the VM size and all this other stuff. So this with machine options directive is something that sets it up once, and any subsequent resources, any machine resources that run afterwards, any machine image resources that run afterward, are going to pick this information up and use it. If you specify another with machine options, you can actually get some machines on AWS, run them with machine options and with driver for Azure. And now you can actually, the next set of machines are going to go to Azure. You can change the machine options and go to Azure with different options for the next machines. It's built so that you can provision a large number of machines across clouds, across Chef servers, and with different kinds of options, all in a single recipe, because your your cluster isn't always going to be the same thing and in the same place. In fact, that's kind of a bad idea. Like, you don't want to stick everything in one region of AWS, because that thing can go down sometime and you'd still like to be up. So you're going to want to actually provision at least some machines in a different region. So you're going to want to change the options in between. And in this case, even change the driver in between. So after you're done writing the test, you can actually run it. Enough, actually run it. Make it go. And in this case, like, so I've already run this before. Maybe I'll switch the driver over to Azure afterwards so you can see it creating something. Oh, looks like I changed something when so it's going to make only the changes that it needs to make. In this case, whatever it was I changed in the recipe caused it to update some attributes in the PGHBA. I'm not really sure what the difference is there. So it's updating the node there, and then it's going to run the Chef client on that node. You can see most of the stuff is up to date. This is a feature of it. If you're going to describe your whole cluster in a recipe, then it had better be idempotent. Like, you don't want the next time you run it to have a whole nother cluster every single time. You want to be able to modify it and add one machine, but you don't want to have to just stick that in a separate recipe and run it. You want to put it in the description of your whole cluster. So when it hits a machine resource, the machine resource goes to check if the machine already exists. If it does, it doesn't create it. It checks if the machine has already run Chef Client. If it hasn't run Chef Client, then it will kick it off again. If the cookbooks that it needs, or the run lists that it needs to run, have changed since the last time we ran, then we kick off a Converge again. But we try not to do work unless we absolutely have to. So why don't we switch that over to Azure? And so what I'm going to do is use the exact same cluster recipe, and I actually haven't run the Azure driver since yesterday, so we'll see what it does. It's going to crash. So how about we do Vagrant? We'll see if that crashes too. I have modified the recipe since the last time I ran it. Okay. So what I'll do to show the new machines right now, rather than attempt to debug my whole project, is add another machine into the recipe that we have here, which is also entirely possible to fail since I modified the recipe while you guys were walking into the room to make it prettier. But it's fairly unlikely. What could go wrong? Oh, that's not even create a new one, is it? How about we make a web 2? Woo! And I could use a for loop because it's code. That's the nice thing about Chef in general. Oh, why am I still doing Vagrant? Somebody tell me why I'm still doing Vagrant. No, that I think needs to be a comma right there. You might be talking about a different AWS that's going to screw me later. All right, so while this is running, and hopefully it'll just run for a long time, you'll notice here that almost all of the green text that you're seeing is the Web 2. Web 1 isn't doing anything at all, and that's because Web 1 doesn't need to do anything. Some of the other things that you can do with provisioning include the workflow that we were talking about earlier, where you, as a as you're developing, you bring up the cluster on your local machine. You can run that same recipe on Jenkins or on a CI or CD or delivery, and it can be the actual test of your cluster. You bring the whole cluster up, and then you run something that's pointed at it and have it go. In fact, I've written a test here, so just so you can see an example of a test. A fairly simple one. I just wrote it in a recipe here. Nothing has to be super fancy. What it's going to do is, after this whole thing comes up, it wants to go to, it's going to go find the Web1 machine. It's going to go and grab its IP address, which I clearly haven't run this since the last time I read it. It's going to go grab the, oh yeah, I did get it. It's going to grab the IP address off of that node, and then it's just going to do a get. It's going to go and grab the web page for it, and that needs to be 200, and it needs to be hello world. And what's amazing about this test is that this is far and away, these 7 lines here, or 8 lines, is far and away more cluster testing than most of us do ever. Like this one test right here gets us a huge amount of coverage across the entire cluster. It's going to show me that my database or my web server are installed. It's going to show me that the links are set up. It's going to show me that the library that that I'm using in my Sinatra app is able to actually talk to the database. It's going to show me my select statement is getting the right thing. And it's going to show me that the user is going to see what I expect him to see, which at the end of the day, I hope is what we're all trying to do. This is where I actually, I'm going to soapbox just a little bit. This is the thing that, well, I guess they kind of gave me a soapbox, so it's cool. This is the thing that the single thing that we can do that is going to make our lives the most better is actually test the clusters in our day-to-day lives. This is where DevOps is actually destined to begin, is on the first day of the project. We collaborate on a Hello World app that runs, and a single test that actually hits it. And once you've actually got this basic structure with, and between one good dev and one good ops guy, you're going to get a pretty, like a reasonable start of an app in much less than a day. I don't know how to configure the monitoring stuff. In fact, I tried last night installing Sensu and a number of other things onto these machines, and decided I would do that for the next talk. We're going to be able to make a pretty good start at a cluster, and we're going to be able to make a test that does this. And after that happens, I, as a developer, if I'm developing this app, I can now focus on the user, the end user tests that I actually want. I can focus on writing code that a user is going to see and writing tests that act like the user, so that I don't do what I normally do, which is test a component, one of my 3 or 4 different components that are supposed to run in a giant distributed system. Just run one of them and test it. Get my 80% coverage, and then ship it to ops and say, hey, can you deploy that? And it's no wonder our applications fail so miserably so often the first time we try to put them in the cluster. Something that you've never run is likely to fail, as I demonstrated twice today very cleverly. So that's my main soapbox. I think that if we can get if we can collaborate on the cluster cookbook, collaborate on getting the app into it, collaborate on starting it out with monitoring tools and logging, like put one log line into this Hello World application that you've created, put one performance monitor being sent off, and the cost now of building an operable app that actually works when we put it into production, that doesn't frustrate everybody and make everybody hate each other, goes up hugely. The earlier we can do a cluster, the better. Let's see what time this is over at 3:55. So I'll do one thing. I'll talk about Docker and the driver that. I'm going to talk about the driver that I rewrote on the plane rather than the one on the one that existed before it, because I like it a lot more. And that'll be released sometime in the next few weeks, because when I wrote it on the plane, I didn't run it yet. But what it does, working with the new Docker API, what I wanted to be able to do was, from my machine, provision the hosts that are going to be running all of my containers. So go up into AWS or Azure or my Metal or Vagrant and actually use the Docker Cookbook, which worked great. I just stuck recipe Docker in there and it worked, and I was pretty happy about that. And then when I'm done with that, use the same recipe, describe my cluster the same way that I've described it here, and have the Docker driver actually go up to each of those hosts. So I say, I want five web server containers up on host number 1. I want 4 web server containers and one of my databases on host number 2. And I need more room. So please create host number 3, provision Docker on him, and get me 4 more web servers and my second database. Provisioning the host is something that we have to do if we want to actually have a scaled Docker app, and it's something that I think we gloss over a lot. But if you want to scale, at some point you're going to run out of room on the boxes that you have, and you're going to have to provision some new ones. So I have an application that looks the way I wanted it to, I believe, sitting in Chef Provisioning. Assuming I didn't delete it. You know what? Instead of trying to find it, I'm going to write it. So if you want to make a host, you're going to write something that looks like this, and say recipe Docker in your host, and then you can make another host. Let's say this is x.rb2. Any commas in there? No. There's already an x.rb, but I don't care. So we can make a couple of Docker hosts. And then at Converge time, which is a new directive that I added there, once those 2 machines have been actually created, then we use the with Docker host directive, which creates a tunnel, an SSH tunnel up to the remote machine, because the Docker API, you never want that actually listening publicly on your machine because it doesn't have authentication. You're at most going to have it listening on localhost. So what we do is we actually tunnel up to it and talk through an SSH tunnel so that locally we can talk to the API and it forwards the requests up to the Docker host. That's how we can hit a whole bunch of different hosts and create containers on all of them, find the containers that are already there. So I can do this and say, with that Docker host, I want to create one of my containers, which is going to be that web container. I've already built an image that I'm going to pull from the repository that is the base web image. And then I create as many of those containers as I want to create. And it's just going to instantiate them. Sometimes you will run Chef on the container. Sometimes you will not. There are times when there is, in fact, like every time, whenever you get over more than 4 or 5 shell script, lines of shell script, things can get a little bit unwieldy. And it can be nice to use a configuration language to configure it. So the other thing that this new version of the driver will do is it does canary converges against the machine. It does it will spin up a container to configure that mounts Chef externally from the host, so that Chef is never a part of that image. You don't want it the whole point of a Docker container is to have just the minimum files that you need for your process. Even if you want to use Chef to configure it, because that's a nice DSL, you don't want it to stay on the image with all its Ruby. So it'll mount up that on the host. It will mount the Chef configuration and cookbooks, or it will put those into temp, and then it will run the Chef client. And when it's done, it will save off an image, and from that, we'll actually spin up the real container in the normal Docker manner with just the process and the config files that are in it. The Canary Converge is, if you actually do want to update a running container, and there are many people who do not want to, and there are some people who do want to do it to get their job done, what it's going to do is it's going to leave that container up, take the image that it was based from, and then create one of those Chef client containers, mount Chef, and put the configuration into temp, and run it. And what's interesting about it is we leave the container up and running, so there's no interruption in service from that particular process. If the Converge actually changes anything, then we commit the image, destroy the container, and recreate it. But if it doesn't, we just leave the thing running and throw away the configuration container. And that's why it's called a Canary Converge. We just bring it up to see if there might be any changes to the image. And that way you're not affecting what's actually happening in the running process. So I'm pretty excited about that coming up. One more thing that I will say is we have the mission is to provision all the things. And we've made a really good start of that in the AWS driver. You can create VPCs, subnets, security groups, pretty much anything that you need to create the network that surrounds your machines. And we're not stopping there. We are just charging ahead with resource after resource to try to build out a good ecosystem so that you can configure all the things that matter to your cluster as code. So the 1.0 version already has all the networking stuff and most of what's in EC2. And 1.1 will not be long, because we are doing the continuous delivery that we've been talking about all the last 2 days. The next thing that's going to happen is that the Azure and the Docker drivers are going to get those same things. You're going to get those new beta resource group things in the Azure driver, and make it so that you can configure more specific things in the Docker container that aren't just machines. So I'm going to stop there. We have a few minutes. If anybody wants to ask questions, you can. And if people want to ask more questions, I'll stick around at the Chef booth afterwards. There's I think a microphone's being passed around. Why don't you shout your question while we're looking for other people?
So architecture-wise, there's a provisioning Chef server that spins up, and that spins up a Chef server in Eden or whatever. But is the provisioning server long-living? If the environment's long-living, the provisioning server stays around, right?
If the environment's logged in.
Long-living.
Oh, long-living. Yeah, so in the ephemeral cluster, where you're just going to make it and you don't care about it and you may kill it later, that's one where you're probably just going to run Chef 0 on your laptop, and it's going to store the information about the nodes on your laptop. And so if your laptop dies, you're going to have to go to AWS and delete them. You'll lose them. But that's a problem if you're in a long-lived environment. If you're going to store that list of nodes, you're going to want a Chef server in production. So the way that works, in general, you've got this cluster recipe that can spin up your whole cluster. What you do is you create a provisioner recipe that can spin up a provisioner. And the recipe that's on him is the cluster recipe. So we're going to say machine provisioner recipe cluster. He probably also is going to need to set up to make sure that he has the right keys to actually provision things on AWS, and so you'll have to use the files directive to copy out whatever keys you want on him. So the way this works is like this is going to be new provisioner is going to be on your Chef server, your central Chef server. It's going to be managed by it. All the other machines that he creates, when he boots up, he runs the cluster recipe and creates the whole cluster right there and then. Whenever there are updates, you check in a new copy of the cluster cookbook. And since he's running every 15 minutes or whatever you have, he will notice that you've added some new machines or changed the recipes that need to be run on them or whatever you've done, and make those modifications, create the new machines, modify the existing machines. So if a machine is terminated, if a machine goes down, then he will notice that and heal that machine as well. That's one of the benefits of idempotence. Here, he's going out and checking what's live, and if that machine isn't live, then he'll replace it. The provisioner machine, there's a related question like who watches the watcher, and who's gonna, if he goes down, who's going to fix him? And the two solutions that generally come to mind are that you keep a monitor that is monitoring it so that you can find out and you can just boot one up yourself if you want. And the other solution is you answer everybody else watches the watcher. You put that provisioner recipe you used from your laptop to create the provisioner, you put it on every single other machine in the cluster, and somebody's going to notice that he's dead and reconstitute him, and then he can start fixing everybody else again.
So we've got time for one more question.
So you covered how to add and change machine resources. How about deleting?
Okay. Tell you what, I'll show you the most destructive recipe in the world. I don't remember why I did it this way. You could do a node search. There's a lot of ways you can do it, but this just says, give me the list of all my nodes on the Chef server and destroy them in parallel. Yeah, so you can, all of the objects you can create, whether it's in AWS _ VPC, and by the way, if you look in the Chef provisioning repository under docs/examples, you can see some examples of VPCs there, and we will put an actual structured example of a VPC application into the Chef Provisioning Central repository soon. That's a priority. So you can say action destroy in any of these, and it'll destroy the machine. And we use destroy because we really like, that's a much stronger word. And one of the guarantees that Chef Mental or Chef Provisioning makes is that we will not destroy anything unless you type the word destroy. So you don't have to worry about putting something in and it's like, well, you told me that this machine had to be a T1.micro and it's a T2.micro, so I'm going to destroy the machine and bring it up as T1.micro. So you can do that. You can put those things and it'll just die and say, I can't do that without destroying your data. Maybe you should tell me to do that because I don't want to do it myself.
Cool.
Okay.
Well, thank you everyone for joining. Hope you enjoyed the session. Just to let you know, at 4 p.m. we're doing our Chef Awards ceremony over in the sponsor exhibit hall. So if you went to lunch today, same area, just don't go in the lunch area. Just you'll see everyone standing around. So that starts at snacks, alcohol, everything you could ever want in life. Yes.
Thank you.